In this video, we will continue programming our Crestron driver and further examine dealing with feedback from the device regarding the power state. You may have noticed in our earlier simple Windows testing, feedback was provided that should not apply to our driver, as we have not included the entire response string in our JSON file. Responses were provided for both power on-off status, warming-cooling status, and input selection. What is happening within the driver framework is that initial feedback is faked deliberately to provide the desired immediate response to the button press or command request. The driver can then update or reinforce the status with true feedback following response from the device or via polling for status. There are components from the driver framework we need to interface with to affect these behaviors. We will first deal with the raw responses within our validate response method. A good first step is to return a base call to allow for more gathering of data if the message is not correct or complete. Then, code is added to remove the header and footer bytes before returning the validated data. Of interest now is the command group. When a command is sent, the command group used to issue the command is stored and applied automatically to the response data if no match is found to feedback in the JSON file. The command group determines how the validated data response is processed. In the simple debugger trace, there are several debug lines reporting a call to DeconstructPower. There are multiple deconstruct methods to choose from based on the response command group, so it is up to the programmer to determine if the framework will set the command group or if their code will before returning validated data. We can interrupt this built-in call by overriding the deconstruct virtual method to perform the actions we would like. For power control, the command group is power. So within the protocol class, we override DeconstructPower. Take note of the variety of deconstruct methods available to use. Our DeconstructPower method will need some way to determine which state of the power cycle it is in. At the top of our protocol class, we can declare constants with the expected responses. Next, we utilize a switch case to provide a place to customize behavior during each portion of the power cycle. At this point, we are only interested in the power on feedback state. We will set the power state feedback to be on while the projector is powered on, warming, or cooling. When the projector is powered off, we will set this feedback to off. In our next video, we will load and test our driver, checking the current condition of our power state feedback. Thanks for watching.